Hello, and a warm welcome to all the audience of this course. I am Dr. Gaurav Tyagi, Associate Professor in the Department of Civil Engineering, NSR University, Warangal, Telangana, India. So, in our course, which is entitled Analysis of Truss Structures and Numerical Approach, we are today going to start our lecture number 2, which is entitled Method of Joints. So when we talk about method of joints, we have to understand that each joint of a truss is subjected to a concurrent force system. We can enforce equilibrium of each joint by isolating the joint, representing the member forces converging to the joint, and external load applied at the joint by making a free body diagram. So what does it mean? It says that each joint of a truss is subjected to a concurrent force system. That means if we see in this figure, which I'm going to make here, example that this is my truss. Okay. For example, this is the truss. So there will be supports and each joint will face a concurrent force system. That means if we consider any joint, for example, joint A, okay, this is B, this is C, this is D. So if we isolate joint A, there will be forces in this fashion. Okay. Any joint we talk about, the forces are either emanating from that joint or terminating at that joint. So all the joints are facing a system of forces which are concurrent in nature. Concurrent means they are all emanating or terminating at one point. Okay. So our job, as it says, is to isolate the joint. First of all, we have to isolate the joint which is representing the member forces. For example, if I talk about a truss like this, okay, and this is A, B, and C. So if I isolate joint A, I will write here FAB, I'll write here FAC, and it will be having my vertical reaction at A and horizontal reaction at A. So the isolation of joint results in representation of the member forces. So member forces are FAB, FAC. So here you can see by isolating the joint, you have written FAB and FAC. Okay, converging to the joint and external load applied at the joint. So if there is an externally applied load also, you can represent it here. Okay, now we have to write two independent equations of force equilibrium, which can be solved independently of other joints as if there are at most two unknown member forces. Okay. So we have to write now the equilibrium equations as I discussed also in the last part of the previous class, that we have to write equations. Let's say this is F1, F2, F3 and so on and so forth. I have to write equations summation Fx equal to 0 and summation Fy equal to 0. Okay. So I'll write here again Fx equal to 0 and Fy equal to 0 summation. This you have to ensure. If you do this, you will have two equations, and two equations can uniquely solve only for two unknowns. Okay. So I have to ensure that at every joint there will be at max two unknown forces only. If there are more than two forces, then my method of joint will not give me the exact solution of the unknowns. Okay. So if we do this for every joint of the structure, we obtain a system of linear equations, right, which can be solved independently of other joints. If we do so, we will obtain a system of linear equations whose unknowns are the internal member forces. If we can find a solution to this system, we have set each joint in equilibrium, and therefore the whole structure is also in equilibrium. Okay. So we are now going to discuss that how can we apply this principle in a practical problem. Okay. So here we are having a practical problem. As you can see here, we are having a truss which is having three external loadings. Okay. 10 kilonewton, 10 kilonewton, and 10 kilonewton. And there are joints which have been named, and we have to find out. Question statement is find out all member forces. Okay, we have to do this. We have to find out all member forces. So how do we begin? So first step would be obtain support reactions. Obtain support reactions. Okay. So your first job is to find out the support reactions. So for that, first of all, we have to name the support reactions. So here will be E. So okay, so I call it VE. Okay, vertical reaction at E joint. Similarly, I will have here VA, and I will also have HA. Okay, because it's a pin joint, so HA is also going to be there. But at the roller support at the joint E, we are only going to have my vertical reaction. So now we have to find out these reactions. Okay, so how to do it? We will apply for entire truss I summation fx summation fy and summation m equal to 0 equations, these three equations which I have. So let me apply summation m a equal to 0. If I do that, so the distances are not mentioned, so here you can take the values. All are 3 meters, 3 meters, 3 meters, 3 meters. These are also 3 meters. Okay, so these are the lengths of the members. Okay, so now if you apply summation ma equal to 0, the equation would be 10 into 3 plus 10 into 6 plus 10 into 9 is equal to VE into 12. Okay, because summation ma equal to 0 means all clockwise moment are equal to all anti-clockwise moments, or the summation of them is 0. So VE is giving an anti-clockwise moment and about a point, and all these three are giving clockwise moment about a point. So summation of all clockwise, which is this 10 multiplied by 3, this is 3, this 6 is for this one, and this 9 is for this one. Okay, so now if we calculate these values, it will come 30 plus 60 plus 90 equal to 12 times of VE. If I solve it, I will get 0, 18 divided by 12 equal to VE. So my VE comes out 12 ones are 12, 12 ones are 12, and 12 fives are 60. Okay, my VE comes out to be 15 kilonewton. Now I can apply summation second equation, summation Fy equal to 0. That will give me VA plus VE equal to 0. This implies VA plus 15 equal to 0 That means VA is also equal to, sorry, VA plus VE is not 0, but 10 plus 10 plus 10, 30. Okay. So VA also comes out to be 15 kilonewton. Okay. So you have determined VA and VE. Okay. So now you can proceed for other joints. Okay. So my VA is 15 and VE is also 15. Now I will isolate joint A. Okay. And I will apply the equation of equilibrium for joint A. Okay. So let us do that. This is my joint A. It is having FAB and this is FAH and this is 15. The angle would be 45 because perpendicular as well as base value are equal. So this angle is 45. So summation fx equal to 0 gives me FAB cos 45 equal to 0. Okay? No, this is not correct. What is not correct? I didn't add FAH. Okay? So this is FAB divided by root 2 plus FAH equals 0. Similarly, summation Fy equal to 0 gives me FAB sin 45 plus 15 equal to 0. That gives me FAB by root 2 equal to minus 15 and FAB comes out minus 15 root 2 kilonewton. Okay. So we have successfully found out FAB. Now, if I put this into equation number 2, I will get the value of FAH. So FAH is equal to minus 1 by root 2 times of FAB, which is minus 15 root 2. So minus minus plus and root 2 cancel. This comes out to be 15 kilonewton. Now, important thing to see here is that this symbol is negative and this symbol is positive. This is positive and this is negative. So negative means the sense of force is opposite to what we assumed. We have assumed all the member forces with the outward arrows, and outward arrows means tension. So outward arrows are tension. Okay. So now I'll give you some time. You can just find out the member forces at joint H. Okay. Try it on your own. You can pause the video for a few seconds. Okay, so now let us proceed to joint H. So here is my joint H. It is having a force FHG, and here is my FBH. It is my FAH, and this is my 10 kilonewton. FAH I have already found, this is 15. Okay, so now doing the force equilibrium at joint H, I can say that FHG is equal to 15 kilonewton and FBH is also equal to 10 kilonewton. Okay, this is by summation Fx equal to 0, and this is by summation Fy equal to 0. Okay, so these two also we have found out. Now coming to the third part at joint B. Okay, if we consider joint B, we have the following situation. This is my FBC, which I don't know. This is my FBH, which I just now found out, 10 kilonewton. This is my FBG, which is unknown. And here is my FAB, which I have found out before, minus 15 root 2. So always remember that you set the arrow directions of all the forces as outward, and whether your answer comes negative or positive, directly use that numerical value. Don't make this negative sign as positive now, because we have found out it is compression in nature. Because if it is compression in nature, you will have to put the arrow inward, and that will little bit make your calculations difficult. So just avoid all that. Directly use minus 15 root 2, because that's the answer we have got before, and use the outward arrows only in all the problems. That will keep your life simple. So this angle is 45, this angle is also 45. So I can calculate summation Fx equal to 0 gives me FBC plus FBG cos 45 is equal to minus 15 root 2 cos 45, which is again 1 by root 2. This is my equation number 1, and I can solve it. FBC plus FBG by root 2 equal to minus 15. I have another equation from the equilibrium of forces in y direction. So summation Fy equal to 0 gives me 10 plus minus 15 root 2 sine 45 plus Fbg cos 45 equal to 0. If you solve this, you will get the value of Fbg directly. Okay, so what is that value? Root 2 cancelled out. This give me minus 5 equal to minus Fbg by root 2. So Fbg comes out to be 5 root 2 kilonewton. And if you put this back in this above equation, you will get FBC. FBC is equal to minus 15 minus FBG by root 2. It becomes minus 15 minus of 5 root 2 divided by root 2. It becomes minus 20 kilonewton. Okay, we have found out FBC and FBG. It's not visible. FBC equal to minus 20 kilonewton. Now I'm going to rub this all and focus on joint C. Okay, so all of you can note it down by pausing the video, and let me move on to joint C. Then I need the values. So FBC is minus 20, FBG equal to 5 root 2, BH equal to 10, G equal to 15, and FAH equal to 15. Okay, so these are my forces which I have found till now, and if I now focus on joint C, so I can rub this page only. So now if I focus on joint C, I have the following situation. There is FCG, there is FCD, and there is FCB. Okay, FCB value is minus 20. So I can directly write FCD equal to FCB equal to minus 20 kilonewton. And I can also write FCG equals to 0. Okay, so this is 0 and this is also minus 20. Fine. So now we can see that we have covered almost half of the truss. Okay. Now, in a similar fashion, you can calculate for member DE, DF, FE, GF, and GD. Okay. You can calculate this on your own. However, there is an important thing which you can see here. Thing is that the beam is symmetrical about its vertical plane. Okay. So if I just copy this, already there, you can check that if you consider the symmetry of this plane, the two sides of the figure is the mirror image of each other. Okay, and because of that, symmetry leads to same member forces in corresponding members. The important thing to note here is that not just the figure itself should be symmetrical, but even the loading needs to be symmetrical. Okay, here you can see 10 kilonewton, 10 kilonewton symmetrical. This could have been anything, 10, 20, 30, 40, whatever, because it is coming at the mirror plane. Okay, but the important thing is on the both sides of the mirror, there are mirror images. Loading is symmetrical as well as all the member forces are symmetrical. Okay, you can see all members are symmetrical. Okay, and because of this symmetry, these are symmetrical members, and because of this symmetry, all the member forces are going to be symmetrical. So if it was minus 15 root 2, this also is going to be minus 15 root 2. If this was minus 20, and this minus 20 we actually found out also. If this was 5 root 2, this will also be 5 root 2. And if this was 10, this is also going to be 10. If this is 15, this is also going to be 15. And if this was 15, this is also going to be 15. And FCG we have actually found out as 0. Okay. So here you can see that by the principle of symmetry, we could see that the member forces in the corresponding members are going to be equal. If we don't want to go by symmetry, we can actually do the calculations also, and you will find that it is indeed true that the member forces in the corresponding members are equal. So with this, we finish our present problem. Let's move on to the next problem, which is this. Okay. We are having in this problem 3 members, okay, AC, AB, and CB. We are having support reactions at A and B, and we are having a single 10 kilonewton load at 45 degrees from horizontal. For this case, we have to calculate the member forces. Okay. So this is an interesting problem, although it looks simple, but it is not. So your job is to find out the member forces and support reactions. So I'm writing the question statement here. Question: find member forces support reaction. I am making a copy of this figure because I may use it again. Okay, a small copy I'll keep with me. Now let us proceed to finding the member forces. Before we do that, don't you think that it makes sense to find out the support reactions? So if we do that, we know that this angle is 45. Okay, so I can find out this member. This is actually 10 kilonewton. Okay, so this is 10 cos 45 and this is 10 sin 45. Okay, so that means effectively I am applying here 10 by root 2. This is also 10 by root 2. Now let us find out the support reaction at B. To do that, I'll write here VB and here I will write VA and HA. Now, if I do the moment equilibrium about A point, I will get VB into 3 is equal to 10 by root 2 into 1.5 plus 10 by root 2 into 1. Okay, that's the case. VB into 3 is equal to 10 by root 2 into 1.5 because it's an isosceles triangle. So this side and this side are going to be equal and the value will be 1.5. Okay. So if you calculate this, what you will get? You will get 3VB equal to 15 plus 10, 25 by root 2. So your VB comes out to be 25 divided by 3 root 2. Okay. Similarly, you can find out VA because VA plus VB equal to 10 by root 2. So VA comes out to be 25 by 3 root 2 minus VB. Sorry, this is 10 by root 2 minus VB, which is 25 by 3 root 2. Okay. So I multiply it by 3, it becomes this. So the answer comes out to be 5 by 3 root 2 kilonewton. So I have got VB, okay, and I have got VA also. Using VA and VB, you can find out the member forces, okay. So if I focus on joint number C, anyway, this photo is not getting, so you can take a snapshot of this and I'm going to rub this portion, okay. So now let us rub this and try to find out the member forces. So VA equal to 5 by 3 root 2, VB equal to 25 by 3 root 2. Okay, so I'm rubbing the other part. So now if I take my joint B, it is 25 by 3 root 2 and this is FCB and this is FAB and the angle between them is this angle tan theta equal to tan theta. This is my angle theta. So tan theta equal to 1 divided by 1.5. Okay. So this is nothing but 2 by 3. Fine. So if this is 2, this is 3, this becomes root 13. Okay. 3 3s are 9 plus 4 13. Okay, so this is my theta. So if I apply summation Fy equal to 0, what I will get? I will get FCB sine theta plus 25 by 3 root 2 equal to 0. That means FCB into 2 by root 13 equal to minus 25 by 3 root 2. And that's my answer. FCB equal to minus 25 root 3 by 6 root 2. Okay, this is your FCB. And similarly, you can proceed for finding FAB. And once you have found out FAB by putting FCB into this equation. So FAB plus FCB cos theta equal to 0. Put your FCB value here and get FAB. Once FAB is also found, then you can proceed to joint A and apply moment equilibrium in following way. FAB and this is FAC, the only unknown remaining. Okay, so that one you can find by applying the sole equation of equilibrium. Thank you very much. We finished this class for today. In the next class, we are going to see some more details of methods of joints. Thank you very much.